Good afternoon, everyone, and thank you for attending our Design Options for Low-Cost UL-Approved Cable Assemblies webinar. My name is Ryan Wood, the Content Marketing Manager here at Epec. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, just enter them into the questions panel, and that is located in the webinar control panel, and we'll try to get to all of them at the end of the presentation. If we don't have time to go through all your questions, we'll be sure to reply back to you by email. Also, we will be recording this webinar and posting both the recording and the slide deck on our website and YouTube channel. Our presenter today is Stephen Goodman, our User Interface and Cable Assembly Product Manager. Stephen is a mechanical engineer with a Bachelor of Science and MBA from Northeastern. As the User Interface and Cable Assembly Product Manager here at Epec, Stephen works closely with customers to provide solutions to specific problems during design consultation and, where needed, helping with the creation of specific designs. So, without further ado, I will pass it over to Stephen.
Thank you, Ryan. Good afternoon, everybody. Again, my name is Steve Goodman, and I'm one of the product managers here with Epec. This afternoon, we'll be discussing some design options to help bring your cable assemblies to market with less cost and less risk with UL-approved cable assemblies. First, the agenda. We'll be discussing at a high level the product safety requirements and how they apply to these types of cable assemblies and discrete wires. Next, we'll be discussing the sourcing and logistics challenges and additional considerations with the global supply chain and marketplace that we work within. Next, we'll be discussing options for both single conductor and multi-conductor wire solutions. Then we'll be discussing ways to customize your build while still being compliant to the existing UL specifications. Lastly, we'll touch on ways to get started with your custom build. First, product safety requirements. So, in terms of regulatory and product safety requirements, it's important to note that there's both system-level compliance and component-level compliance. And what we mean by system-level compliance, it's more specific to the types of products. These types of products are typically energized, complete enclosure with a circuit board. Some of these have embedded firmware, logic, and even cellular transmission devices. But overall, these are standalone units, typically box builds, something that's a complete design that a user can plug into a wall, turn on, and use accordingly. Because of this, there's a variety of specifications that exist that are largely tailored to the industry that the device will be used. For example, the Consumer Product Safety Commission is a federal standard that covers a variety of products, really focusing on child safety type of products and issues. IEC 60601 is a system-level medical specification that we can tailor our designs to be compliant to. But again, these are all system-level products, tests, and so forth. For the mil-aero industry, Mil Standard 810, DO 160, and Mil Standard 461 or other system-level type requirements and specifications. Focusing more on the component level, these types of products must be installed in a next higher assembly for them to function. Some specifics, product types include jacketed wire as shown on the screen here, surface-mounted devices like capacitors, LEDs, and even off-the-shelf products. Some of these specific specifications are broad, like the Appliance Wiring Manual, UL 758. Others are more specific, which cover a unique wire configuration such as UL 1007 or UL 1430. The mil-aero specification that speaks to component level devices is Mil Standard 202. And generally speaking, when you look at the data sheets or manufacturers' cut sheets and spec sheets for these types of products, those high-level specifications mentioned on the previous slide are boiled down, and there's typically some derivative of those system level specs that's contained on these individual data sheets. So why is this important? Product safety is an obvious thing, and why it's important. But more importantly, agencies like UL and so forth, they help bring products to market with that initial certification. This demonstrates that the new design has been independently reviewed by an unbiased business entity and asserts that the performance is as described. This is also important because, as we all know, with the changing supply chain issues that everyone's facing, material changes and obsolescence are inevitable. These product safety accreditations help make certain that if a material is changed, such as a wire jacket, that the material change itself will not create an undue risk for either the user, the consumer, or the manufacturer. Additionally, these third-party testing entities will perform site visits at the facility or factory where these products are made and perform this at some periodic interval. This is a continuous and ongoing type of activity, and audits can be yearly or even more frequent. Lastly, and most importantly, these accreditations are globally recognized. Now, it's important to note that if you're bringing your product to market in another country that's not the United States, Canada, or parts of Europe, there may be additional tests and certifications that are required. People's lives depend on these products functioning properly. Next, we'll be discussing some of the challenges with sourcing and logistics of these types of products. First, it's important to note that there are, generally speaking, 5 phases of product development. This ranges from your proof of concept device, some 3D printed samples that either you source online or you can do in your own lab, the first production samples or the first parts off the tool, your low rate initial production, and finally, your high volume mature production. Each one of these has its own unique requirements, timelines, and expectations from both the technical team as well as the end user or customer. It's important to consider what the stakeholders need at each one of these 5 phases in the development life cycle, because when you're considering one of the thousands and thousands of wire options, the worst thing for your project is to identify, for example, a high minimum order quantity type of wire cross-section if really all you're trying to do is a proof of concept device. So it's important to note Epec's core competency is on the production side of the development life cycle. If you have a couple units that you want to build and show your manager, Epec is not the best solution to get you 10 feet of wire. There's many other solutions out there, and we're happy to work with you and recommend a readily available wire type. But there's dozens of electronics distributors who have this wire. It's relatively inexpensive, and you can get it probably within a couple days. Once you've done your initial testing and you've identified the type of wire, the requirements, and what the overall build needs to look like, we can help build those first production samples. Whether it's 2 pieces, whether it's 100, or because of your timeline, you need to waive samples and move right into production, we can support all of that. We're set up to rapidly scale from development to production with a global supply chain. More about our global supply chain. To support our harness manufacturing capabilities, Epec has a global footprint. The majority of our wire harness activities are centered between here, where I'm based, our New Bedford, Massachusetts corporate headquarters, and our various supply chain partners spread across Southeast Asia. Additionally, Epec has core competencies in machining and mechanical assembly, so that if the cable assembly you needs to go inside a box build, or you need a custom machined back shell. These are all core competencies that Epec can support in bringing your product to market. Additionally, one of the ways Epec can help our customers get to market faster with less risk is the fact that we extrude our wire in Southeast Asia. This is co-located in the same facility where we strip, cut, assemble, and overmold the majority of our cable assemblies. There's several benefits to the customer, but overall it helps get product to our customers faster with less cost and reduced overall risk. I don't need to remind the audience here how heavy wire is, but once you get to the 16 gauge, 14 gauge, even larger than 10 gauge wire, the weight of wire exponentially increases as the diameter increases. Having your assembly facility co-located where you extrude your wire reduces the number of shipments, which has a direct reduction in cost. More about Epec's global footprint and our sourcing strengths. Interestingly, Epec is one of UPS's largest New England regional customers. Accordingly, we have access to favorable freight rates, greater shipping capacity, and through our activities to consolidate in Hong Kong, it further reduces the number of shipments over the ocean and helps you, our customers, get to market faster with less cost. We all know costs are going up, especially over the past year. According to recent studies, the U.S. has seen freight rates increases of almost 30% year over year. This fact, coupled with the United States and the world entering peak season, which is really from mid-August through the end of Thanksgiving, we don't expect the shipping challenges to go away anytime soon. Additionally, with the implementation of tariffs applied to imports from Southeast Asia, we don't see these going away anytime soon. Epec shares this cost burden with our customers. It's important to note that these tariff costs and this tariff exposure does not apply to tooling or NRE. It only applies to the production value of the cable or widget. Next, we'll talk a bit about single and multi-conductor wire options. The UL spec covers, in general, the internal wiring of appliances. Now, these aren't necessarily appliances in the sense of dishwashers and refrigerators. It's more specific to an electronic device that is used either in the household or some consumer type product. But these wire classifications are extremely common. They're also known as hookup wire if you look through the electronics distributors. And they're typically available in both single and multi-conductor fashions. Flammability ratings are some of the most critical requirements for these types of cable assemblies. And as we will discuss, specialty type designs can be achieved, but the overall UL accreditation can't be violated. There are things that can be changed within the design that do not violate the UL certification, such as the shielding methodology and type. Some common shield methodologies include a braided shield, a metallized foil shield, which is typically a mylar or PET with a conductive material on it, and then coupling those with a drain wire if need be. Speaking more about UL 758, which is an overarching appliance wiring material specification, it can cover dozens and dozens of UL specifications. Listed here are more than 50 UL specifications that we are approved to produce. This covers both single conductor wire shown at the top and multi-conductor wire shown at the bottom. Each one of these unique numbers on the screen has its own characteristics for voltage, temperature, wire jacket material, and other requirements above and beyond. More about these types of wiring options. Choosing a wire option that is readily available helps get to market faster with less risk. Single conductor, multi-conductor, and flat cables are among the most common wire types. And along those lines, there are dozens and dozens of UL specs that correlate to each. What's important is that this wire is in stock, that it's available, usually in minimum order quantities of 1,000 feet or less, and it's something that we can rapidly scale and build. For example, if you need 1,000 cables using one of these wire types, that's no problem. If you need 10,000 cables, we have the capacity and build plan to rapidly scale and offer the same lead time or a pretty close lead time, even for medium to high volumes like that. Another consideration when looking at readily available wire options is to make certain that the temperature ratings and voltage ratings align with your program needs. Each one of these unique wire types is designed and qualified up until those thresholds. Next, a bit about automotive grade wiring options. Though these don't explicitly meet UL, a lot of times these wires can also meet the generic UL specifications. So for example, SAE J1128 defines several types of thermoplastic, tough, high temperature rated wire jacket options. These are typically defined by the minimum diameter of the wire with insulation, as well as the maximum allowable temperature and voltage rating. Next, we'll be discussing ways to customize your build It's important to note that when going to market with a new design, care is taken to make sure that it's manufacturable. And what we mean is that putting together a wire bundle with several dozen twisted pairs is no problem. But there is a finite number of pairs we can stuff within a certain cross-section. It's always recommended to work with your supplier or your manufacturer to review the ease of manufacture for any custom wire extrusion. It's also important to note that custom is not necessarily expensive. In fact, it can be low cost, just like a comparable UL wire. But a minimum order quantity must be satisfied. Epec can support complete customization of these wire types. This can include dozens and dozens of wires, all mixed and matched of different sizes, all within the same wire bundle. Epec can also vary the shielding methodology between those wire bundles so that some twisted pairs have a shield and a drain, some twisted pairs are unshielded, and then the overall bundle can have a shield. All of these things don't necessarily violate a UL compliance as long as the voltage and temperature rating is not violated. Additionally, adding an overmold itself won't void a UL unless, as mentioned before, it violates the specification for voltage rating, temperature rating, or some flammability rating. Most wire jackets within this family are thermoplastic. The overmold materials are either identical or a chemically comparable material. And in many of these, the overmold material is actually PVC or another thermoplastic matching the wire jacket. So here shown are several wire designs with custom overmolds, all of which are house tools where Epec has the tooling in place and readily available, all of which can be used for a $0 NRE expense. If additional customization is needed, Epec can add artwork, logos, polarity markings, and other information to your custom overmold. Next, we'll talk a bit about how to get started with your custom build. First, with the initial engagement with Epec, our sales team will ask you to fill out our cable assembly inquiry form. This short document allows our team to capture all the relevant technical and program information so that we can quickly review and respond to your request for quotation. For customers who have never built or purchased a cable assembly before, there's also information here that helps your team go and further assess and vet out what information is needed to build the product. Once we've had a chance to review the system requirements and the program objectives, our engineering team will require some sort of drawing or sketch. Now, there will be projects and requirements that are so simple that we don't need a drawing. But at the end of the day, we will still push and require for some document or information that allows our team to make bid assumptions and put forth a fixed price quotation to our customers. In addition to some type of drawing or sketch, we need to know the performance requirements and really what you're trying to accomplish with this cable assembly. The spec or design should include the wire specs, a wire gauge if one's been defined, and some kind of pinout or schematic of the assembly. Most of our requirements are very simple, where continuity testing alone is sufficient, but some of our customers will require more, and we can support. For those activities, we do request that our customers send us the appropriate test specifications, whether this is environmental testing or some kind of mechanical or bend testing. We need to know how the design will be impacted by the environment and abuse it will see in the real world. Lastly, once complete, Epec will perform a review for manufacturability and communicate with our customers any design risk that we see. This can be something as simple as a mismatch between the wire gauge and the rated wire gauge for a crimp. There are times when a wire is too big and it simply won't fit within a crimp. We can identify that and notify our customers. Other things may involve a pin pitch or a minimum bend radius, but overall, our goal is to review the design for manufacturability and report back to our customers with areas of risk that we see. Lastly, and most importantly, we want to point out, give us the requirements of what you're trying to accomplish, and our team will figure out how to build it or identify the roadblocks that prevent us from building it. Here's a very brief, high-level summary of a typical timeline bringing a custom USB cable to market. This is riddled with assumptions. We need to use a common wire that's readily available. We have both UL2464 and UL2725 wire readily available at our facility in Asia. We also have house tooling for the USBA overmold shown on the screen here. If there's no changes to either of those and we can use the industry standard for both, Epec can build samples in as short as 5 weeks and get those parts to you for fit checks, for testing, and so forth. Next, we'll go through our summary. So in closing, when considering global sourcing, don't forget about the total costs for the product in its entirety. And what that means is, although your quote from a TBD manufacturer may give you a unit price, do your homework, do your due diligence, determine if this is FOB of Hong Kong or where the product's shipping from. Make sure that there's no NRE costs that are not accounted for. Depending on where the product is built, there may be tariffs involved. There's also additional freight charges and duties depending on where you're sourcing and shipping this. Do your homework, and if there's questions, a company like Epec, we can help dive into the details and give you a roadmap for what the projected costs will be for whatever the scope of work. Next, if you're unsure where to start, focus on the voltage and temperature requirements of your cable. That'll help you narrow down the vast number of cable designs that exist in the world that are compliant to UL. Next, it's important to note that UL does allow the mixing and matching of wire sizes and conductor counts such that there's no violation of the temperature, voltage, or flammability ratings. Another key takeaway from today is the fact that if you just need a few feet of cable, we would love to help and we can recommend one, but we may not be your best option to get 5 or 10 feet of a 28 gauge wire for your testing or whatever you need. If you need design consultation, we can support, we can steer you towards a readily available cross-section, but at the end of the day, there's many electronics distributors online that can probably get you 100 feet of that wire much faster and for much less than we can. And lastly, we always recommend building samples first. This is important because with any new design comes some degree of risk. It's very easy to dismiss the risk and push forward building product at risk. But at the end of the day, if that product doesn't work, somebody's going to have to pay for it, somebody's going to have to scrap it. If your program can absorb the scrap of 1,000 pieces, wave samples, get all of them at once. Most of our customers aren't able to manage that level of risk, and accordingly, we build samples first on every build, and then we ship them to you. Once your team has approved those samples, we build the balance 500, 1,000, whatever production quantity exists. So with that said, I'm going to turn it back over to Ryan to talk a bit about our products.
Thanks, Steve. While we review the questions that came in, I want to briefly mention some of the additional product solutions that we offer here at Epec, such as custom battery packs, flex and rigid flex PCBs, printed circuit boards, CNC machine parts, user interfaces, flexible heaters, and our energy-efficient fans and motors. Now I'll pass it back over to Stephen to review the questions that came in.
Thank you, Ryan. We've got a few here. We'll jump right into this. What is your process for attaching the wire to PWB? I believe that's a printed wiring board. The response we'd want to give would be to attach a wire to a PWB or PCB. Really, there's two options. You either need to crimp onto something that's then attached to the board, or you're going to solder directly to the board. Some projects actually will do both. The crimped wires are usually attached to some kind of connector. That's then made into a PCB, a header connector, or some type of similar interconnect. It's also important to note that attaching a wire to a PCB, that process itself is not covered by UL, but there are two IPC specs that I can offer guidance on. The first is IPC 610, which is wildly common for us here at Epec. That covers soldering. An example of that would be connecting jumper wires to a circuit board or something of that nature. The other IPC spec worth mentioning is IPC 620. That defines the crimp process of how to attach a wire to a crimp terminal and stuffing that into a connector housing or body or similar. Next question here. We need plenum-rated multi-conductor cable. Can you customize this? No, unfortunately we can't. This is a good question because plenum applications are unique, and they're usually for commercial buildings where wires run within vents and within the ducting of the building. Usually these are high airflow areas that are at severe risk for fire or fire spread. The plenum-rated materials actually are specialty because they're fire resistant, and also they don't emit toxic smoke or fumes. And obviously both of those things are extremely important, but it comes with an added cost and a much smaller supply chain. And to be honest, the plenum-rated cables aren't common for us, but instead the UL wire we do support typically goes into enclosures, mechanical assemblies, electromechanical box builds, and that sort of thing. And with those, the flammability rating we have is VW1 or a horizontal flame rating, and both of which are typically satisfied for those low airflow type of applications. The next question here is, do you have UL material for wire bond? I think this refers to the actual individual wire in the wire bond operation. So with that said, the wire bond operations usually offer a ultra small diameter single conductor strands of wire. It's really just a single strand of copper, and sometimes they'll have a tinning applied to them to help with the soldering operation. But most individual wires used in the wire bonding operations, they're tiny. They're a few thousandths of an inch in diameter to maybe 20 thousandths of an inch. But they're unjacketed. There's no thermoplastic. It's really just copper. So the UL spec doesn't apply to that. All right. The next question here is, what about solid conductor wire? Is this impact UL? All right. Well, this is a good question. So there's usually no impact to UL because most wire types are actually dual certified for both a single solid strand of wire as well as the multi-conductor strands of wire, something that's a highly flexible, almost looks like a wire brush type of cross section. As we've said throughout this, the UL will define the temperature rating and max voltage, but there's no mention of current within the UL spec. That's actually a function of the wire cross section and whether it's a stranded conductor or a single solid conductor. And the latter will actually take a higher current rating. I think the biggest difference between the designs, outside of just the physical appearance of the cross section, is just the overall flexibility of the two. But that has no impact on UL. Next question is, our team needs an inexpensive cable product. Of the cable types Epec presented today, what's your recommendation? That's a good question. We recommend finding the best readily available wire that meets your project's needs. So finding the best is a relative term. So as we said before, I definitely start with the temperature and voltage ratings of your project. Next, you're going to want to study the material of the jacket and make sure that the environment if you're using the cable, will be okay with that type of material. If you're looking for specific UL specs that are inexpensive and readily available that we can recommend, I'd say UL 2464 is an excellent choice. That's a multi-conductor cable. It's wildly inexpensive and it's used everywhere. For single conductor wire, the UL 1007 actually has a dual certification for UL 1569, just really expanding its temperature limits. But that wire type is literally the most common single conductor wire type that we have here at Epec. So I think if your team needs an inexpensive cable jacket or cable product, UL 2464 or UL 1007 are probably your best choices. So that is unfortunately all the time we have today, everybody. But we want to thank you for your time and wish everybody a great weekend. Thank you.